Hello dear students. So today I am going to start the model number 5, 3-phase induction motors. There are two units. The first one is 3-phase induction motors and second one is synchronous generators. So let us begin with the first unit, 3-phase induction motors in model number 5. So what is motor? Motor means which conversions electrical energy into mechanical energy. So that we can call as a motor. Generator means it is a reverse, which converts mechanical energy into electrical energy. So it means that the three-phase induction motors means it is a conversion of electrical input to mechanical output. And see here, the three-phase induction motors are most widely used in industry. Dear students, the induction motors are not only used in industry, in the domestic, in the commercial, and in industry. So most commonly and widely used motor is induction motor. That may be single phase induction motor or three-phase induction motor. So in industry, so three-phase induction motors are most commonly used. But in the domestic or in the commercial purpose, so we can use single phase induction motor, which is sufficient. And the second point is the three-phase induction motors run at constant speed from no load to full load. Means that the induction motors are running at constant speed. Means the speed is not variable. The speed is constant, starting from no load to full load condition. No load means what? The motor is not connected to any load. So that condition is a no load condition. Full load means the motor is fully loaded. Means the load is connected to the motor. So that is the full load condition. So from the no load condition to the full load condition, the speed of the induction motor is constant. It is not variable. So that is one more point. But the speed is frequency dependent. So there is a relation between the speed and the frequency. That is n is equal to 120 into f by p. So n is directly proportional to the frequency. So as the frequency varies, the speed is also varies. That's why these motors are not easily adapted to speed control. And coming to the next point, as we know that in every machine, electrical machine, there are two parts, that is stator and rotor. Similarly, in the induction motors, we have two parts, the stator and rotor. So what do you mean by stator? The stator means it is a stationary part of the machine, and rotor is it is a rotating part of the machine, any machine it is. So coming to the induction motor, the stator carries a three-phase winding. Three-phase means it is a three windings will be there, that we can call it as a RYB. Okay, three-phase winding. So this called stator winding. But the rotor carries a short circuited winding, so that winding we can call as a rotor winding. But remember, this stator and rotor are not physically connected, so there is some air gap between the stator and rotor based on the capacity of the machine or power rating of the motor. Only the stator winding is fed from three-phase supply. It means that it is a motor which is conversion of electrical to mechanical. Electrical input should be given. Where electrical input is given? To the stator or rotor? Stator, the stationary part of the machine. For that, we are going to give the three-phase AC supply. Then the rotor winding. The rotor winding derives its voltage and power from the externally energized stator winding through electromagnetic induction, and hence the name. Why we are saying induction motor is because of the electromagnetic induction, the energy is taken from stator to the rotor, or energy is transferred from stator to the rotor because of the electromagnetic induction process. That's why the name is induction motor. And let us discuss what are the its advantages. The advantages of three-phase induction motors. The first one is it has a simple and rugged construction. Simple means, so compared to other types of machines for the same capacity, the construction of the induction motor or the construction of other machines. So if you compare, so it is simple. Rugged construction means what? Very strong, very rigid, or indestructible in the sense. So that construction is very strong. So that's why rugged construction. That is one of the very advantage of the three-phase induction motor. And it is relatively cheap. Cheap in the sense, not if you compare a same capacity machines like DC motor and AC motor. AC means induction motor. So if you compare 1 HP capacity of DC motor cost and 1 HP capacity of induction motor cost, then comparison the cost is low. That's why it is relatively cheap. And the third point is it requires little maintenance. So as we all know that the maintenance is most important factor once the machine is started using in industry. So the maintenance point of view, it requires very less maintenance. So that is one of the major advantage of having three-phase induction motor. The fourth point is it has high efficiency and reasonably good power factor. So always we are looking at what is the efficiency of the machine, whether it is a DC machine or it's a AC machine. So with respect to the efficiency point of view, it is a very good higher efficiency. So that's why it is one of the advantage and reasonably good power factor. So power factor is also not too low or not too high, but it is a good power factor. So that's why induction motors are most preferable. And it has self-starting torque. The torque is required so for the initial condition, so it has a self-starting torque also. That is also an advantage. But what are the disadvantages? So almost all points we have considered in the advantages: construction wise, cost wise, maintenance wise, efficiency wise, power factor, consumption, starting torque, everything. So there is no points left in the advantages. So but what are the disadvantages means, just we can put one disadvantage, that is it is a constant speed motor and its speed cannot be changed easily. So as we have discussed in the earlier, that is it is a constant speed machine. So that maybe it is not a disadvantage, so but we can keep still, because the constant speed means the speed is not variable. In some applications, if you want to vary the speed, in that case the induction motor may be difficult. That's why we can put this point as in a disadvantage of induction motor. Otherwise, so remaining factors: torque, power factor, efficiency, maintenance, cost, construction, everything, it is an advantages. So let us discuss the construction of a three-phase induction motor. So as I said earlier, in the construction means the parts of the machine, the two major parts. One is the stator part and the second one is the rotor part. Stator means it is a stationary part of any machine. The rotor means it is a rotating part of any machine. So that is rotor and that is stator. But the rotor is separated from the stator by small air gap which ranges from 0.4 mm to 4 mm depending on the power of the motor. So remember, the stator and rotor, the two major parts, both are not connected. They are separated by small air gap. So there is not physically connected stator and rotor, but there is a air gap. And how much air gap is there, that depends on the power of the motor, the capacity of the motor. Usually it ranges from 0.4 mm to 4 mm. So minimum 4.4 mm and maximum 4 mm. So that based on the capacity of the machine. So let us see the diagram, a simple construction of the induction motor. Here you can see the outermost part of the machine. So that is the frame of the machine. Okay, this is the outer part, is the frame of the machine. And next comes the stator winding. So this complete part is the stator winding, the second circle, that is the stator winding. So in the stator winding, we have the slots. See, these are the slot. So we have many number of slots in stator winding, so that we can call it stator slots. What is the purpose of using these slots is to keep the or to put the stator winding, means the circles indicates inside the slot is the stator winding or the stator conductors. The conductors are placed in each slot. So how many number of conductors are placed in a machine, that depends how many number of slots are made in the stator winding of the machine. So if you want to supply, if you want to generate the more output, then the number of slots may be more, and the conductors placed in each slot is also more. So that's the construction of the stator winding. Okay, so frame is a stator winding, the number of stator slots, and these are the conductors placed in each slot. And now here you can see I mentioned the air gap. So there is a air gap between the stator and this is the rotor winding. So 0.4 mm to 4 mm, based on the power of the motor, we can change the air gap between the stator and the rotor part. So in the rotor, this is the rotor winding. Okay, the distance is varies based on the capacity of the machine. That's why I mentioned it here. And you can observe here in the stator winding, we have the number of slots, that's the inner periphery. So here the conductor placed in this location. But in the rotor winding is made in such a way that the number of slots are there in the outer periphery. Okay, the outer periphery of the machine is, we have the number of slots, that is the rotor slots. In each slots we have the number of conductors. That's the winding is rotor winding. So these small circles indicates the rotor winding, and these indicates the number of slots, that is the rotor slots. Next comes the shaft of the machine. So there is again two ends. One is the driving end and another one is a non-driving end. In the driving end, it is connected to the external prime mover. So where we can connect the mechanical load. And non-driving end, we can connect the bearings, so which increase the friction, which decrease the friction losses. Okay, reducing the friction losses. So that is the purpose of using the bearings in the machine. And this is the base of the induction motor. So just I have explained you the parts of the machine induction motor, that is a frame, outermost part of the machine is the frame, which gives the mechanical support to the machine. Okay, and the stator winding, number of stator slots, and this is stator conductors, and the air gap based on the capacity of the machine, and the rotor winding, rotor slots, rotor conductor, and shaft of the machine. So here we have one end is connected to the load, other end is the cooling fan. The fan is also connected to the other end to reduce the heat inside to reduce the temperature inside the machine. And this is the base of the machine. So now let us discuss in detail the construction of the stator winding. The first point is it consists of a steel frame which encloses a hollow cylindrical core made up of thin laminations of silicon steel to reduce the hysteresis and eddy current losses. See, the construction of the stator winding in a three-phase induction motor is, it consists of a steel frame. Okay, this steel frame is enclosed by a hollow cylindrical core. Okay, this hollow cylindrical core is made up of thin laminations of silicon steel. So here we are using the silicon steel, thin laminations of silicon steel, because to reduce the hysteresis and eddy current losses in three-phase induction motors. So there are two losses, that are hysteresis and eddy current losses, which we have already discussed in the transformer, which occurs in the core of the transformer. Okay, so this is a constant losses. Okay, so that's why these losses to be minimized. Okay, we cannot eliminate the constant losses, so the losses can be bring to minimum by using the thin laminations, very thinner laminations of silicon steel material. And the next point is a number of evenly spaced slots are provided on the inner periphery of the laminations. So here you can see in the diagram, these are the inner periphery of the laminations. Okay, inner periphery of the laminations, where the number of slots are made based on the capacity or size of the machine. The insulated conductors are placed in each slot, stator slots, and are suitably connected to form a balanced three-phase star or delta connected circuit. So these circles, inside the small circles in each slot, these are the stator insulated conductors. So the conductors are connected in such a way that it forms a balanced three-phase star circuit or balanced three-phase delta circuit. So there are three windings are there, R, Y, B. So balanced means the phase angle between R and Y is 120 degree, Y and B is 120 degree, and B and R is 120 degree. So that we can say is a balanced three-phase winding. Star means it is connected in star format, that is all three windings are connected to the common terminal, that is neutral terminal, where the one winding is connected to the next winding. So connecting the closed, that is the delta type of winding. The three-phase stator winding is wound for a definite number of poles as requirement of the speed. So we are using the definite number of poles. Poles means there's a north pole and the south pole. So the number of poles is inversely proportional to the speed of the machine. There is a relation ns is equal to 120 into f by p. So if you want more speed, then the number of poles should be lesser. If you want less speed, then the number of poles may be higher. So 120 indicates it is the phase angle between the R and Y, Y and B, and B and R. That is 120 is the balanced three-phase winding. So it is fixed; it cannot be changed. F is the frequency, the input frequency to the induction motor, which is directly proportional to the speed of the machine. So the frequency varies, then obviously there is a change in the speed. But in the denominator, there is a pole. P means it's a number of poles. If the number of poles is 2, then the speed is normally you can take F is 50 hertz. So 120 into 50 by 2, you will get the NS. NS is the synchronous speed. If 120 into 50 by 4, you can do it, then you will get the another speed. 6, then NS is vary. 8, NS is vary. So both are inversely proportional to each other. So if you are go on increasing the number of poles, then the speed of the machine is decreases. If the number of poles is decreasing, then the speed is increases, vice versa. So based on the required speed, we can place the definite number of poles in the machine. That is very important. The next point is, when a three-phase supply is given to the stator winding, a rotating magnetic field, also called as RMF, of constant magnitude is produced. So what happens when you give three-phase input supply to the stator winding? A rotating magnetic field also called as simple RMF, rotating magnetic field is produced, which is having the constant magnitude in the stator winding. And this RMF induces currents in the rotor with the help of electromagnetic induction. Okay, so by giving the three-phase supply to the stator winding, so whenever the current flows through a conductor, the magnetic field is produces around the conductor. So that magnetic field is rotating magnetic field, but the magnitude of the winding is the magnitude of the magnetic field is constant. That is not variable. The constant magnitude is produced. So this rotating magnetic field induces currents in the rotor winding with the help of by the process of electromagnetic induction. So that's why the name is induction motor. Okay. So this we'll discuss in detail while discussing the principle of induction motor. Okay. Okay. The next part of the machine is rotor, which is the rotating part of the machine. The rotor mounted on a shaft is a hollow laminated core having slots on its outer periphery. So remember we have discussed that the stator having the number of slots, that is a hollow laminated core having the slots on its inner periphery, it is outer periphery. So hence you can see in the block diagram again, this is an inner periphery, this is the outer periphery. So that these conductors, because of the electromagnetic induction, the EMF induced in the stator links with the rotor by the process of electromagnetic induction. So that's why this rotor is designed in such a way that the number of slots are made on its outer periphery. Okay. The winding placed in these that windings we can call as a rotor winding. Okay. And the rotor winding may be having the two types. One is a squirrel cage rotor winding or wound type rotor winding. Okay, based on the type of the rotor, so we can classify as a squirrel cage rotor and wound type rotor. So hence normally we can say squirrel cage induction motor and wound type induction motor or slippering induction motors. This type is also called as slippering induction motors, where the slipperings are used in this type of rotor, where the slipperings are not used in this case. Okay, let us discuss the first one, the squirrel cage induction motor or the squirrel cage rotor. The stator remains same for both squirrel cage as well as the wound type. Remember, the stator is the stationary part which is remains same. The same stator can be used for both squirrel cage and wound type, but the rotor used inside the stator, okay, that is maybe different. That may be the squirrel cage type. That's why the name is squirrel cage induction motor. That may be the wound or slippering type. That's the name is slippering induction motor. So how the squirrel cage rotor is constructed? See, in the squirrel cage rotor, so we have the two end rings. So this shading lines indicates two end rings, both the side of the rotor core. And inside we have these lines indicates these are the skewed construction type. Okay, so this is short circuited. This is a hollow cylindrical core laminated type. So these are the rotor bars. The rotor bars may be of copper or aluminum, and these skewed rotor bars, okay, are permanently short circuited to the end rings. So this is connected to these all these lines indicates these are the rotor bars which are permanently short circuited. So that's why the name, this looks like a cage. Okay, that's why the name is squirrel cage rotor or squirrel cage induction motor. So let us discuss in detail. So it consists of a laminated cylindrical core having parallel slots on its outer periphery. One copper or aluminum bar is placed in each slot. So these are the number of slots the lines indicates. So in each slots, the copper or aluminum bars are placed, and all these aluminum or copper bars are joined each end by these metal rings, or also called as end rings. So these are all joined. Okay, it's completely short circuited, and this forms a permanently short circuited winding which is indestructible. Means it's very strong, we cannot break it. So the entire construction, like bars and end rings. Bars means these are the bars, lines indicate the bars, these are the end rings. So the entire construction of using the bars and end ring resembles a squirrel cage. Okay, and hence the name is squirrel cage rotor or squirrel cage induction motor. And this design is also made to, because of this skew type construction, so we can reduce the noise also in the machine. We can reduce the noise and we can bring the more stability up to the machine. So that is also the advantage of having the skew type construction. So we can reduce the noise at full load condition. When the machine is running at full load, in that condition there will be possibility of having the more noise, so that can be reduced with the help of the this type of design. And we can give the more stability, more rigidity to the machine. Means indestructible, very strong. Okay, in other words, so the rotor is not connected electrically to the supply. Okay, because the stator is connected to the electrical supply, but the rotor is not connected any electrical supply directly, but it has current induced in it by the transformer action from the stator. The transformer action means what? It is the mutual induction which induce the voltage from the stator to rotor. Actually, stator we are giving the direct electrical supply. So because of the transformer action, because in the transformer also we have seen primary and secondary winding. The primary winding is not connected to the secondary winding physically, but because of the mutual induction process, the primary induced voltage links with the secondary winding. So the same principle, the transformer action, the same principle is applies in the induction motor also. Stator we are giving direct three-phase supply. The rotor also we are getting the current is induced in the rotor, but they are not electrically connected. Means there is no electrical supply to the rotor directly from the stator to rotor. So with the help of transformer action, the current is induces. So again, this one we will discuss in detail in the working principle of an induction motor. The second type of rotor is wound rotor or slippering rotor. Okay, so it consists of a laminated cylindrical core and carries a three-phase winding. The rotor winding is uniformly distributed in the slots and usually star connected. So the same, so there is no change in the construction wise. Same, it also having the cylindrical core laminated with the help of silicon steel material, and which carries a three-phase winding. The winding may be connected in star or delta. So, but usually it is connected in star. Okay, I will discuss later. And the open ends of the rotor winding are brought out and joined to three insulated slip rings. Because of the star, so other ends will be open. Why we are connecting star? If you take the delta, what happens? There is a closed loop. One end is connected to another end like this. Okay, this triangle shape. But in the star, we have the one end will be open like this. Okay, so the open ends of the rotor winding is brought out and joined to three insulated slip rings. So the open end of the rotor winding is connected to the slip rings. That's why this type of motor is also called as slippering induction motor. Okay, mounted on the rotor shaft with one brush, slip rings and brushes. Each one slip ring, one brush, and one winding. Next, like RYB, three slip rings to RYB and three brushes to RYB, like that, resting on the each slip ring. The three brushes are connected to the three-phase star connected rheostat. Here you can see the block diagram of the wound type or slippering induction motor. At starting, the external resistances are included in the rotor circuit to give the large starting torque. So one disadvantage of having three-phase induction motor is it is a low starting torque. The starting torque is lower if you take the squirrel cage induction motor. So because of this type of construction, see this is the rotor winding, okay, RYB. The each winding is connected to the one slip ring. This indicates the slip ring, and the shaded line, the shaded above the slip ring, we have the brushes. So three slip rings and three brushes, and this is a RYB, three-phase winding. So each brush is connected to the rheostat. The terminal is connected to the rheostat. Okay. And what happens using this terminal rheostat? The resistance, the resistors are included in the rotor circuit. So because of this, we can increase the starting torque. We can get the larger starting torque by varying the rheostat at starting. Okay, initially we can vary the rheostat, so we can increase the starting torque of the induction motor. But later, these resistance are gradually reduced to zero as the motor runs to full load speed. So once the motor gradually picks up the speed, so then the rheostat again it brings to zero. So but this additional mechanism which is not available in the squirrel cage induction motor. So that is a once the motor is designed in squirrel cage, that cannot be changed. But in the slip ring induction motor, so we can add an additional external resistance. Rheostat means it's external resistance. So the resistance can be varies. As the resistance varies, the current through the winding is varies. If you adjust to more resistance value, then obviously the lesser current will flow. If you bring it to zero, then more current will flow. So this can be varied as per your requirement. So then once the machine's speed is pick up rated speed, then the resistance are gradually bring it to zero. So this is the extra additional mechanism in the wound type or slippering induction motor. Otherwise, the construction wise, the working, everything is remains same as that of the squirrel cage induction motor. So dear students, so I will stop at this point. So we have discussed the introduction to the induction motor, advantages and disadvantages, the construction of the induction motor, that is stator and rotor. Again in the rotor, we have discussed squirrel cage rotor and slip ring induction motor. So in the next video lecture, I'm going to cover the three-phase working principle of a three-phase induction motor. Okay, thank you.